Hey, welcome to the Explainer. So today, we're going to pull back the curtain on the digital world. We're going to uncover the hidden mechanics of how your data, well, gets from your screen, travels all the way across the globe, and arrives at its destination in literally the blink of an eye.
So let's kick things off with a question you've probably never even thought to ask, but it's happening all the time. How in the world does a message or a photo or a video find its one specific path through the trillions and trillions of possible routes that make up the internet?
Well, the secret sauce, if you will, is something called network switching. The best way to think of it is like the internet's ultimate traffic control system. It's constantly making these split-second decisions to guide your data along the most efficient path it can find at that exact moment.
All right, so here's what's on the docket today. We're going to start with what I'm calling the dedicated path. Then we'll move on to the relay race and finally land on the modern highway that pretty much powers everything we do online. We'll also dig into the two different flavors of data packets and then wrap it all up with the switching revolution. All right, first up is the original, kind of the OG of switching techniques, circuit switching. It is by far the most straightforward way to connect 2 points. Okay, think about it like this. Remember old school landline phone calls? Before you could even say hello, the network had to literally build a dedicated private line just for your conversation. That line was all yours, and nobody else could use it until you hung up. That, in a nutshell, is circuit switching. And it's always this three-step dance, right? First, you establish the connection, that's you dialing. Then you transfer the data, that's your actual conversation. And finally, you disconnect, you hang up, which frees up that private road for somebody else. Now, it's super reliable, but you can see how that's, well, not exactly the most efficient way to use the network, right? Tying up a whole private road for just one chat. Okay, so if having a dedicated private road for every single conversation is kind of wasteful, what's the next evolution? Well, that brings us to a more flexible system, though not necessarily faster. This is message switching. So, with message switching, we completely ditch that private road idea. Instead, your entire message, picture it like a baton in a relay race. It gets sent as one big, complete unit from one router to the next, and each router acts like a checkpoint in the race. And this is the key phrase right here, store and forward. Now really think about what that means. Every single checkpoint, every router has to wait to get the entire file, the whole message, store it, and only then can it pass it along to the next runner. You can probably already see the big glaring problem here, can't you? It creates a huge delay at every single stop. Right, so that built-in delay, it makes this whole method a total non-starter for pretty much everything we do today. Can you imagine your Zoom call or a live video stream having to be fully downloaded at one router, then sent to the next, then the next? It's fine for things that aren't time-sensitive, like an email, but for anything happening in real time? No way! And it's exactly that problem, that massive delay, that forced a totally new way of thinking. It led to the big one, the game changer that makes the modern internet possible, packet switching. Okay, and this is where things get really clever. Instead of sending one giant message baton, the system disassembles your data into thousands, maybe millions of tiny, manageable little pieces called packets. Each one is like its own little parcel, ready to start its journey. And here's the magic. Each and every one of those tiny packets is like a smart piece of mail. It's got the from address, it's got the to address, and this is the absolute key to the whole thing, a sequence number. That little number is what lets us put the entire puzzle back together perfectly on the other side. Okay, so we're breaking things into packets. But even within that system, there are a couple of different strategies these packets can use to actually travel across the network. So on one side, you've got the datagram approach. The best way to think of this is every packet for itself. It's beautiful chaos. On the other side, you've got the virtual circuit approach. This is way more organized, kind of like a convoy of trucks that all agree on a route beforehand and stick to it. The public internet that we use every day, that's built on the datagram approach. And this every packet for itself approach is what makes the internet so incredibly tough and flexible. If one path gets jammed up with digital traffic, a packet doesn't just sit there and wait. Nope, it just finds another way around. They're all independent agents. And the really fascinating result of this is that they can, and very often do, arrive at the destination totally out of order. And that brings us right back to why that little sequence number is pure genius. I mean, who cares if packet number 4 arrives before packet number 2? The computer on the other end just looks at the numbers and rebuilds the message in the correct order. 1, 2, 3, 4. It's just an incredibly elegant solution to a very chaotic journey. All right, let's step back for a second and look at the whole journey we just took. We've gone from a simple, dedicated phone line all the way to this vast, chaotic, but unbelievably efficient network of tiny data parcels. Let's see how that whole evolution looks side by side. This chart really lays it all out perfectly, doesn't it? You've got circuit switching, dedicated, fixed, great for old school voice calls. Then message switching, dynamic but slow because it sends the whole message at once, so it's only good for things like email. And then the king, packet switching. Dynamic, uses small packets, and it's built for, well, everything we do online.
And really, that's the whole story right there. This one simple but honestly revolutionary idea, chopping up data into these tiny, independent pieces, is what allows billions of us to stream movies, have video calls, and browse websites all at the same time on the same shared infrastructure. It is truly a system of organized chaos.
And all this leaves us with a really big question, doesn't it? Packet switching was the solution that built our entire digital world. But when you think about what's coming next, massive AI models, fully immersive virtual reality, billions of smart devices all talking to each other, you have to wonder, what's the next switching revolution going to look like?